It's a fourth grade. Pretty hard to believe, but in exactly 1 month from today, we will all be done with school. It'll be summertime, so we are definitely in the final stretch right now. And today we'll be working on this lesson 16 problem set. I got a red highlighter today. And pretty much what we'll be doing is we'll be adding and subtracting fractions by using number bonds and even number lines to help us. So let's get started. So question 1, pretty easy. All it's asking us to do is solve. So let's start with A. We have 3/5, and we're going to subtract that from 1/5. So let's set this up before anything else. Let's turn this or make this into fraction form. So we have 3/5. What number do you see in 3/5? 3/5. And we're going to subtract that by 1/5 or 1/5. So very important before we move on to anything else. And just a quick review. In order to add or in order to subtract fractions, the denominator, so the number on bottom, must be equal. So they must be the same. They must be equivalent. So for example, if the problem was 3/4 minus 1/3, I cannot do this problem if it looks like this. I would first have to convert it and then solve it. But luckily for today, we do not have to do any converting. We could just go from here. So 3/5 minus 1/5. 3 minus 1 is 2. And my denominator stays the same. So this is how you do it in the standard form. Let's scroll down and I will show you how you would do this using a number line. So we attached a lesson 16 template on your packet just to make it more clear and just so you can have an extra piece of paper if need be. So my problem was 3/5 or 3/5 minus 1/5 or 1/5. And we're all familiar with this number line. So we start off with 0 and go to 1/5 or 0/5, I should say. 0/5, 1/5, 2/5, 3/5, 4/5, and then 5/5. And we are starting off with this 3/5 or 3/5, which is right here. And they are asking me to subtract. So subtract, we already know we're going to the left, we're going backwards. They're asking me to subtract just 1/5. So I'm going to move one place over to the left. And that brings me to 2/5. And that's the same exact answer I got using the standard algorithm way. Okay. Go ahead and try B, C, D on your own. It is your choice whether or not you want to use the number line or you just want to do it the standard way. So let's go ahead and do 2A. I have 5/6 and I'm going to subtract 3/6. Okay, first things first, I need to check if my denominators are the same. Let's check. 6 is the same as 6. Awesome. So my denominator is the same and I'm able to subtract. Denominator will stay the same. And then I have 5/6 minus 3/6. I know from counting, I know from looking at a number line that 5 minus 3 is 2. So my answer would be 2/6. If you want to get super duper fancy, we can also convert this to lower units by dividing the numerator and denominator by 2. This is more practice we'll see in later problem sets, but if you want to get after it, then you can also convert it to a reduced fraction. 2 divided by 2 is 1. 6 divided by 2 is 3. So my answer is 2/6 or 1/3, 1/3. Let's also show this really quickly on the number line. So if I would do this on the number line, I would start off with 0 over 6, 1 over 6, 2 over 6, 3 over 6, 4 over 6, 5 over 6, and then finally 6 over 6. Double checking my problem again. So I started off with 5 over 6. So I started off right here, 5 over 6, and they want us to subtract that by 3. So they want us to move to the left again, 3 spots. So 1, 2, 3, and I once again get 2 over 6. Okay, go ahead and try B, C, D, E, and F on your own. And then let's go right ahead. Let's go to number 3. So 3 is asking us to solve using number bonds. To show how to convert the difference to a mixed number. So first one has been done for you. Great. So this is pretty much the same exact thing we've been doing from above. The only difference is that we're going to be left with a numerator larger than a denominator, and then they just want us to convert it into smaller units. So let's do that. Let's work on B right now. So first things first, we're going to check if my denominator is the same. 6 is the same as 6. So I am able to subtract, and my denominator, my number on bottom, will stay the same. Next, I will move on to my numerator. This 12 minus 5. Okay. Always remember to regroup. Okay, so 2 becomes a 12, 1 becomes a 0. 12 minus 5 is 7. So my answer is 7 over 6. But I'm not done yet because they want us to convert this into a more mixed number, okay? So let's do this. I know that all the students going to office hours are pretty good at this. They know that when the numerator and denominator are equal, that is equal to 1. So let's make the numerator and denominator equal. So let's make 6 over 6 as one section of our number bond. And then, as you guys remember, what would my next section of the number bond be? How would I find this section of the number bond? Well, all I have to do, right, is 7 minus 6. Or 7 over 6 minus 6 over 6. 7 over 6 minus 6 over 6. Okay, I know that 7 minus 6 is 1, and once again, my denominator stays the same. So I know that 7 over 6, if I want to convert that into number form, I would have 6 over 6, and then an additional 1 over 6. So once again, we know that this 6 over 6 is the same exact thing, same exact number as the number 1. So this is equal to 1. And I am left with 1 and 1 over 6. And that would be my final answer. Okay. Go ahead and do C, D, E, and F on your own. And next page, starting with number 4 and 5, all they're asking you is the same thing as above, but instead of subtracting or finding the difference, we are finding the sum and we are adding. So let's do one example. Let's do 4a together. We have 2/4 plus 1/4. Okay, is my denominator the same? Yes, so I'm able to add. What is 2 plus 1? That is easy, that is 3. So I am left with 3 over 4 as my answer. Let's go ahead and show this really quickly on the number line. 0 over 4, 1 over 4, 2 over 4, 3 over 4, and then finally I have 4 over 4. I am starting at 2/4, or 2 over 4. But instead of going to the right or to the left this time, I will be moving to the right because I am adding. So I'm starting with 2 over 4, and I'm adding 1 over 4, so I'm moving 1 time. My new answer becomes 3 over 4. And that is exactly what we got. Okay, so go ahead, try 4B, and then 5A and 5B. I'm going to go ahead and do one more problem in 6, just to show how to convert those improper fractions into more mixed numbers. Okay, so first things first, we have 4 over 4 plus 3 over 4. So first checking to see if my denominator is the same, and it is. So I'm able to keep my denominator and I'm able to add. 4 plus 3, that is 7. I'm going to make a number bond for this. This one is actually pretty easy because we could have already seen what is about to happen, but just for fun, let's do it this way. So what would go over here in my number bond? Well, just 7 minus 4, right? So that would be 3 over 4. And we know that all we were trying to do is get the numerator and denominator equal each other, because we know when the numerator equals to the denominator, that is just equal to 1. And we're left with 1 and 3 over 4. Okay, so a pretty new concept, but fairly easy once you draw the number bond and once you differentiate those fractions. Okay, so go ahead and do 6C, D, E, and E, that's not what I wanted, E and F on your own. And also try number 7 on your own, and they are asking you to use a number line to model your answers. So this is totally optional, so you could do it the standard way or use a number line. But try A and B, and that just about covers it. So what we did today is we are using addition, using subtraction, to find sums, to find differences by using the standard algorithm and by using number lines.